Hi everyone. So next we are going to talk about the projectile motion on an inclined plane. Projectile motion on an inclined plane. It's very easy. So look at this. So initially we have discussed oblique projectile motion and then we discussed the half projectile motion. Now we are discussing the projectile motion on an inclined plane. Okay, so in the inclined plane we already studied some where in Newton's first motion, right? So the motion I'm in a wedge and all. Okay, anyways, so here I will explain the basic things first. This is the inclined plane. This is the inclined plane. This is the plane's x-axis. This is the plane's y-axis. So now the plane's x-axis, okay, x dash y dash. This is the real x-axis, and maybe I can say this is the real y-axis. So now the alpha is the angle, that is the inclined angle of inclination or inclined angle, that is alpha, and theta is the usual angle. Look at this. This is exactly how this projectile, that is oblique projectile motion, I kept it in a this one. What is that? I kept it in an inclined plane. That's it. Okay. Now ay is equal to, then acceleration will always act in this direction. So we are considering the acceleration along the perpendicular to the inclined plane as well as parallel to the inclined plane. So look at this, A parallel is equal to minus g sine alpha. So it will come g because this direction is positive, this direction is negative. So g sine alpha, g cos alpha. If this is alpha, this is also alpha. Okay, that's a mathematical, pure geometry. Then how much is A perpendicular? That is equal to g cos alpha. G cos alpha. This we need. And what about u parallel and u perpendicular? That we already studied. That is in oblique projectile motion. U cos theta, u parallel, u sin theta, u perpendicular. Now the time of flight. What is time of flight? Time of flight is the time taken to complete this projectile motion. So let's start. Let me tell you something. We will always consider time of flight and maximum height as exactly similar to the oblique projectile motion, and then we will add the conditions in it. Okay, we will add the condition in it. So time of flight t is equal to 2u sin theta by g. T is equal to, we can also write what is u sin theta. If you have doubts, you can look at this one. Okay, we need this one. So u sin theta is nothing but u perpendicular divided by a perpendicular. Okay, so just apply u perpendicular from this one, a perpendicular from this one. The answer is ready. Okay, look at this, how simple it is. How simple it is. This is a shortcut method. This is a shortcut method for that. So let's check. It is u perpendicular. A perpendicular, because in oblique projectile motion, this is what is g perpendicular. Now next, similarly, maximum height. What is the maximum height of oblique projectile motion equation? H is equal to u square sine square theta divided by 2g. U square sine square theta by 2g. And how much is h, by the way? U perpendicular square, that is u sine theta the whole square. That is u perpendicular, u sine theta the whole square. U into sine theta the whole square divided by 2 into a perpendicular, g. So then I can write h is equal to u square sine square theta divided by 2g cos alpha. Okay, so but there is a small problem. When you consider horizontal range, you cannot take this thing. Okay, you cannot consider this thing. So look at this, horizontal range you consider s is equal to ut plus half t square. So I just want this distance, this much distance. How much is that? That is a parallel distance travelled by the projectile. So I can say that r is equal to, that is total distance is equal to r. R is equal to u parallel into total time. That how much is that? Time of flight. D plus half into a parallel into t square. So just apply the values, all the u parallel from there, a parallel from there, t from here, all the equation, substitute all the equations, substitute a parallel, u parallel, t, then you will get it. So you apply the values, then r will become, that is then solve it, r will become 2u square by g into sin theta into cos theta plus alpha divided by cos square alpha. This is very important formula. You just all keep in your mind. sin theta into cos theta plus alpha divided by cos square alpha. So by using the mathematical thing, that is application of derivative, maxima and minima, that is you didn't study that, right? So you haven't studied that yet. You will study, all right? So then you will get the idea. So now I'm not going to going too much detail into it. So look at this. R maximum, that is the range is maximum when theta is at an angle pi by 4 minus alpha by 2. Always remember pi by 4 minus alpha by 2. Next step, how much is that R maximum? That R maximum value, if you are throwing the ball in this direction, that is going upwards in the inclined plane, then it is u square by 1 plus sin alpha. And if you are throwing from up to down, that is just like this. If you are throwing in this direction, then that is R max is equal to u square by 1 minus sin alpha. These equations only you just keep in your mind. And how would we get this equation? When you put this value, theta value here. Okay, that is the thing. And I think it's pretty easy. And only the formulae, we need only the formulae. Nobody is going to ask you the derivation or anything. So this much is projectile motion. So projectile motion is entire, the lead portion is over. And now we have to solve some problems. I know that you must have done the problems that I have given. Now we are going to talk about circular motion. We'll introduce the circular motion and then we'll continue the circular motion in the next class. Alright, thank you.